Everyone, welcome back to the DevOps Bucket. Today in this video, I am explaining you how to create a load balancer using Ingress resource mainly in EKS Auto Mode. Previous video, I explained the differences between EKS and EKS Auto Mode, what makes to create a new feature called EKS Auto Mode from AWS, and how to create the cluster and how it works and what are the features of it. Everything I explained in the previous video. If you didn't watch that video, please go and watch the video. The link is in description and also in the cards. Okay, now where I'm explaining today to create a load balancer. So I have created one cluster with auto mode, and if you see the EKS auto mode is enabled here, and in the compute section you see that there is one system node created current now. Let me go to the cloud shell to connect to this cluster and do the ALB creation. Let me connect with this cluster using the AWS EKS update -cube config -fn name is this name of the cluster. Okay, and enter. So yeah, now my cube config has been updated. If I see kubectl get nodes, able to see that one node has been created, right? Yeah, now let me create a one resource file resource.ml. Okay, which it contains namespace, service, deployment and ingress resource, because we are now creating a load balancer through ingress resource. Previously in normal EKS you need to install one ALB load balancer controller, otherwise an Nginx controller. Any of ingress controllers you need to install in your cluster and then write the ingress.ml file with the routes and the host and the backend services, etc. Right? Yeah, whenever you are using EKS Auto Mode, the feature of ALB controller will comes out of the box. So you need to create a one additional resource called ingress class. Okay, you need to define the ingress class, and then you need to add that ingress class in the ingress resource. Now we are going to see that. Okay, let's go to this document. This is a deploy sample load balancer control workload to EKS Auto Mode. There is one game application called 2048 kind of application is already provided by AWS to practice. So now we are using this. First I am creating this namespace resource. Okay, and then first let me do this thing to keep the format of the files. Okay, I'm copying this file and I'm creating the namespace here. Okay, after the namespace I am adding this deployment YAML file, which is creating on the same namespace, and also the image. If you see, this is an sample image of 2048 application and remaining configurations are normal only. Okay, and along with it I said you you need to create a one ingress class. Okay, that ingress class resource is this, which I am naming it as a ALB, and I am just using this ingress class name while creating the ingress resource. Okay, let me create this service will points to deployment. After that I'm copying the ingress class. This ingress class will be referred in the ingress.yaml file. This is the one. Okay, if you see, there are two annotations that are added. One is scheme is internet facing and target type is IP, which means we are creating a load balancer that is public facing, which will be accessible via internet, and the targets of the load balancer and the part of target group is the IP. So the pods that are directly will be attached to the target group IPs, and if any issues come and the pod will restart it, then ALB controller will take care of it to deregister and register the original targets, like correct targets. Okay, and this is the configuration. Whenever anyone reaches to the /star, then it will be reroute the traffic to this service is pointed to a deployment of this. Okay, so this is our configuration. I am just pasting here. Okay, I pasted here. Then let me save this, and before applying it, I would like to tell you one more configuration over here. If you see, these many subnets I have in my VPC. Let me open the VPC. Okay, if I go to the VPC, so whenever I am creating a load balancer, right, so I need to specify the subnets on which the targets should be available, so that the load balancer should also create on those subnets. As you know, the load balancer require at least two subnets, I mean two availability zones, right? Because one availability zone, it will not work, right? Yeah, so how the load balancer will detect the subnets? There are two ways. One is to give that subnet values, okay, subnet IDs in the ingress.yaml file that we have creating here using another annotation called subnets. Okay, but if you don't want to do that, instead you want to ALB controller or AWS will auto detect your subnets. In that case, you need to do one thing in your subnets. You would like, and you need to add one tag. If I open this, there are few subnets that are already having this tag. Okay, this is for tag for a public load balancer. Okay, if you don't want a public load balancer, you can add a tag with the internal, then it should be an internal load balancer subnets. Okay, let me copy this tag and let's go to the subnets and open the another subnet tags. See, there are no tags here, right? That means this subnet will not be associated to the load balancer automatically, because this AWS cannot be this EKS control, ALB controller or this controller cannot detect these subnets to be attached. Okay, and in that case you will see that target groups are added, but the target groups are not linked with this any of the subnets that ALB has selected, so you can't able to use them. Okay, it will show you like that. So instead of adding the annotations in your ingress.ml, you can also do this way. Okay, let me add for every subnet. Now every subnets are being added with the tag to auto detect the load balancer, right? Now let us go to the cluster again. Okay, and now let me apply the YAML file created. So now what we did, we created one deployment, one namespace, one deployment, one service, one ingress resource, and a ingress class also. Okay, to create it. And also while doing it, we are giving a tag to the all subnets, so that we are saying that please select all these subnets while creating the load balancer. Okay, kubectl apply fnf resource.ml file. Okay, now I am applying it, so everything has been created. Now let me check the kubectl get namespace. Okay, now let's check with the pods. Okay, the container is creating now. Why? Because maybe that the node that is came up now only. See, if you see the 8 seconds one, that's why you can't able, you just observe that the container is creating now. Within a second it will be in available state. Yeah, now it is in running state. Let's see the kubectl get ingress in that particular namespace. If you see, one load balancer endpoint is already connected. Let me show you one more thing. Kubectl get pods -a. If you see this, I don't have any controller created here, because this controller will come by out of box. Only thing that we need to create is a ingress class. If I go to the EC2 section to check the load balancer, okay, if you go over here, load balancers is in provisioning state. If you see, all these subnets are attached. How it will be attached, I haven't mentioned anything in my ingress control, right? Ingress resource .ml file. So it is auto detected because we have added those tags in the subnets. Okay, then you see this 80 port as a listener, and there are two rules. One is for whenever anyone reaches to this, it should go to this target group. 5 targets, those are all our pod IPs, right? You see this target registration is in progress. If the subnets are in different the subnets, there are some other subnets and your pods is in different subnets, then you can able to see here is this subnet is not allowed for the load balancer. Okay, while reaching to this load balancer, we need to check the security group that was attached, right? So if we go to this here to the load balancer section, if you open this, it is inactive now. Okay, if you see the security, there are two security groups that were auto created by controller. One is the manager security group, another one is the backend security group. If you see, both of one is for the outbound rules 0.0 and another one is for inbound rules of 80. So anyone who contacting this load balancer on 80 port should allow its traffic. That's why they are giving it 0.0, because it's a public facing, and outbound rules are allow all. Okay, okay, let me refresh this. See, now those are in healthy state and 5 are healthy. Let's access this. Copy this DNS name and just go over here and just run. You will able to see the load balancers game. See, this is the game. Okay, if you able to see it, right? New game. Okay, now you are able to understand this, right? How to use ALB controller and ALB, create ALB resource from the EKS Auto Mode. So that's it for this video. If you would like to know such kind of use cases, please comment it down below. I will try to do it. and I am also continuing this series of auto mode to show you much more use cases and the troubleshooting steps as well. I hope you got something new in this video. Thank you.